In this video we will investigate the effect of polarity and electrodes shaped to the formation of electric spark. We will use an electronic 15 kV high-voltage generator to create the spark. The high-voltage generator needs a 5 to 12 volt DC, which can be provided by this switching power supply. This power supply has terminals to connect the AC inputs and DC outputs. The voltage can be adjusted using a variable resistor. The power supply has been connected to the high-voltage generator, which is connected to the electrodes. The red wire is positive while the black wire gets negative voltage. The positive and negative electrodes have the same shapes, representing blunt and sharp edges, but rotated by 180 degrees. This creates two gaps with similar width between the electrodes. We want to know if the polarity and electrode shapes can determine which gap will generate spark. This time the spark occurs on the gap where positive voltage is connected to the sharp electrode. Now the electrodes have been rotated 180 degrees. This time the spark occurs on the gap where positive voltage is connected to the blunt electrode, which means it is the same gap that produced spark previously. Let's repeat the last setup, but the blunt loop wire of negative electrode is slightly deformed to reduce the gap. This time the spark occurs on the gap where positive voltage is connected to the sharp electrode. This indicates that the width of the gap has more significant impact on the occurrence of electric spark compared to the shape of the electrodes. Now ones of the conductors have been flipped so the gaps are constructed by electrodes with the same shapes. They are adjusted to similar width. This time the sparks occur alternately between those gaps. Now the gap between blunt electrodes has been slightly reduced. This time the sparks mostly occur on the blunt side. This confirms our previous conclusion that the width of the gap has more significant impact on the occurrence of electric spark compared to the shape of the electrodes.